In order to understand how we can write and describe intervals of values, that is, types of solution sets we get when we're dealing with inequalities and other scenarios, we have what's called interval notation. We talk about this in terms of open intervals and closed intervals, and then half open, half closed intervals that are their own special case I'll get to in a second, where what we have is, if we write the value a comma b with a and b in parentheses, we are making what's called the open interval, where in set builder notation, we would write this as the set of values x such that, the vertical bar always means such that, x is between a and b. That is, a is less than x, which is itself less than b. And then on the other hand, we have what's called a closed interval, where we write this in square brackets, a comma b, and this is the set of x values such that x is between them, but can possibly be equal to either. That is, a is less than or equal to x, which is itself less than or equal to b, where if we have situations that we are including an infinite value in some sense, we're looking at, say, x values bigger than b, we don't include infinity. And on the other hand, if we're looking at values, say, less than a, we wouldn't include negative infinity, where the idea of set builder and interval notation actually is a fairly recent invention, decided to better represent groups of values that follow a specific rule, such as being trapped in an interval of values. And I could go in here with a few more of these like special general cases, but really it's a lot easier to see and understand how this interval notation works with a couple of more concrete examples. So for this example, we want to express each interval in set builder notation and then graph it on a number line, where our cases are the half-open interval from -2 to 5, the closed interval from 1 to 3.5, and the open interval from -infinity to -1. So with our first case, where we're going from -2 to 5, what that says is we want the values from -2 to 5 along the number line, where we are including -2 but not 5. So this would be the set of x values such that -2 is less than or equal to x, which is strictly less than 5, and it would look like so on a number line, where sometimes you'll see those square brackets to indicate that something's included, other times you'll see a filled dot, and then you'll either get a parenthesis or an open dot to indicate that something is not included. Meanwhile, in the second case, we don't have to worry about that quite as much because we're doing the closed interval from 1 to 3.5, so our set will look like the set of x values such that x is less than or equal to 3.5, while itself being greater than or equal to 1, which I'm aware I said backwards, but I think you get the idea. And then finally, for that last case, we're looking for anything less than -1. So as a set, we would write that as the set of x such that x is strictly less than -1, and on the number line, that's just an open parenthesis at -1 and then everything to the left of it. Where, again, we can use dots if we'd like, but this is the general idea for what our notation looks like, where it's also worth setting up another piece of notation here in terms of being able to find combinations of these sets through things called unions and intersections.